Hello friends, welcome to our YouTube channel. Today we'll be helping the calculus student, the beginner. So in solving or in understanding the basic parts of calculus. Now today we're doing differentiation. Now so I'll firstly be doing differentiation from the first principle using two methods. Okay, now before we have power rule and the first differentiating from the first principle. Now before the power rule, I'll be teaching you differentiating from the first principle. Okay, let me write out some examples. We'll be doing examples. Now example 1, you have a function y equals x. You're told to differentiate the function from the first principle. Okay, I'll be teaching you two methods to be using here. Okay, so either you use this method or the other method I'll be teaching you. Okay, what you have to do is to add the increase in y to the left hand side. I add the increase in x to the to the right hand side. This is what I mean. The increase in y, that is the change in y, and the increase in x, that is the change in x. Okay, so we have this y plus change in y equals x plus change in x, and um recall that our x is 1, is y. Okay, so and we also recall that our y is x, so you can substitute x for y here. That is, you have x plus change in y equals x plus change in x. So you have to collect like terms, that is the one that is common. So x and x, they are the same thing. So you have x minus x plus change in y equals change in x. So x minus x gives us 0. So I have change in y equals change in x. So divide both sides by changing x. So dividing both sides by changing x. So I have change in y over change in x equals 1. Therefore, the differentiation of function function y equals x give us 1. So that is the dy dx, or change in y over change in x of x is 1. Okay, the other method I will be teaching you, if you don't want to use this, now don't forget that you have your fx. You can call this your y fx. You have fx equals x. Now if you want to find the differentiation, so you say f prime of x, that is differentiation of x, will give us fx plus h minus fx now over h. So take the limit of h tends to 0. So take the limit of h tends to 0. Okay, these are our f of x already, so we add h to our f of x here to get our f prime of x. So we have f prime of x equals x plus h, that is limit of h running to 0, minus f of x, which is x over h. Okay, now what you have to do next is to collect the like terms. X minus x is just 0, so you have h over h, that is limit of h tends to 0. So you have f of x equals limit of h tends to 0 of 1, that is the limit of a constant to 0 is that constant. So you have f of x, that is f prime of x, give us 1. So either you use this method or you use this method. Okay, now let's do another example. Example 2. Now you are given a function, that is function of y equals root of x, and you are told to differentiate this. Now let's use this second method, that is from the first principle. This is my f of x. My f of x equals root of x. Now, so to find f prime of x, don't forget the formula. Limit of h running to 0 of fx plus h minus fx over h. Okay, so we have f prime of x equals limit of h running to 0 of x plus h, root of x plus h minus root of x over h. Okay, now what you have to do next, we can't apply our limit directly like this. We're gonna get wrong answer. Now what you have to do is to multiply the numerator and the denominator by root x plus h plus root x. Now this is what I meant. So you have limit of h tends to 0 of root of x plus h minus root of x multiplied by root of x plus h plus root of x over h into bracket root of x plus h plus root of x. Okay, so this is what I'm saying now. So if we expand this, we get, using this algebraic identity, a plus b multiplied by a minus b give us a squared minus b squared. Now you can see this is our a and this is our b. So I have limit of h tends to 0 of root of x plus h squared minus root of x squared over h into bracket root of x plus h plus root of x close bracket. So this squared, we cancel this root, this squared, we cancel this root. So we have limit of h tends to 0 of x plus h minus x over h into bracket root x plus h plus root x. Okay, now x minus x give us 0, so you have h over h into bracket root of x plus h plus root of x. So you apply your limit of h tends to 0, so h cancel h, so you have f prime of x equals limit of h run to 0 over root of x plus h plus root of x. So you apply your limit, that will be 1 over root of x plus 0 plus root of x. So root of x plus root of x will give us 1 over 2 root of x. So we have 1 over 2 root of x. Therefore, the differentiation of root of x from the first principle is 1 over 2 root of x. So if you like this kind of video, please don't forget to subscribe, like, share and comment to my videos, and don't forget to on the notification button anytime we upload film on basic, we upload videos on basic calculus, so you're gonna be the first person to watch it. So it will be interesting. It's just started the basic calculus. So after the differentiation, we'll be moving to integral. So I will be teaching you everything about differentiation. So after that, I teach you the basic integrals. So I love you all. Thank you.